graph the derivative function whose graph is shown below. This is the function f. I want to graph the derivative. Alright, well, if you think about it, since f is linear, it's a line, the derivative is the same at every point, right? Another way to think about it is the derivative at any point is just the slope of this line, right? And so if you find the slope of this line, the slope of this line is going to be starting from here. You can rise, run. So the slope of this line is -2, right? So the derivative at any point is -2. So sketch the derivative. Well, it's just f prime equals to -2. So then you just draw a line, a horizontal line, -2. This is the graph of f prime, and you're done. Okay. All right. Example number 7. The figure below is the graph of f prime, the derivative of the function f. On what interval is the graph of the function f increasing or decreasing? So in example 7, we kind of reverse the process. You are looking at the graph of f prime, the graph of the derivative, and we are to use this information to determine where our original function is increasing or decreasing. Okay, so remember, the original function will be increasing when the derivative is positive, right? Positive. When the derivative is positive, remember that? When the derivative is positive, these are positive derivative, the function is actually increasing. And positive derivative is graph above the x-axis. So, going back to this problem, this is the graph of the derivative. We start to search and find out where the derivative graph is above the x-axis. So clearly, it is above the x-axis between x1 to x3. So our original graph will be increasing on the interval of x1 to x3. Okay. The original graph is decreasing where the derivative is negative, right? So the derivative is negative there, and it's also negative there, right? So our original graph would be like decreasing from 0 to x1 union with between x3 and x5. Alright, so if I were to sketch the graph of the derivative, which you don't have to, but if you do, here's what it would look like. The derivative is negative. That means that my graph is decreasing, so I can draw a graph that decreases, see? And then it stops decreasing there, and then it increases, and then it increases, and then it becomes 0. See how it becomes 0? The slope is 0, right? And then it continues to decrease. It continues to decrease until it reaches 0 again. So 0 is where it kind of flat out. See, 0 is where it kind of flat out. All right, and that would be the graph of the f function. Okay, and it makes sense if you think about it. You know, on this interval, the slope is all negative, and that's why these are negative numbers, right? Graph is increasing, the slope is all positive, and so on and so forth. Okay, awesome job. I am proud of you guys. I'll see you guys in class.